In this video, we're going to take on the TryHackMe Advent of Cyber 3 2021 edition, day 2. And without further ado, let's just kind of dive into it, you know? So hey, I do have to apologize, guys. I'm sorry, I'm not in costume anymore. The vibe, the illusion, the artifice of Christmas spirit and holiday cheer is gone. It has abandoned us. But we can at least still have some fun with the advent of cyber here at TryHackMe. So hey, I'm over at tryhackme.com/Christmas over on my screen here. If you scroll down, and if you haven't already, you can join for free. Join the room, AOC, and get ready to play. We got the ball rolling just yesterday for the TryHackMe Advent of Cyber 2, or Day 2 task. So many numbers at this point. Never mind, I'm not going to say that. Edit that part out. If you haven't seen the introductory video or the kickoff video that I helped kind of put together for this TryHackMe Advent of Cyber event, you can find that on my channel, and I hope you enjoy. Anyway, let's get to the good stuff. We just finished up the day 1 Save the Gifts activity, but now we're moving on to the day 2 Elf HR problems. And the story behind this, give me a little bit. I will read through the story and just cover all this high-level stuff. So if you're already a wizard, if you're already a guru, you already know what we're talking about here, feel free to skip forward in the video. But if you are someone new getting started in the field of cybersecurity, let's learn what we can learn together here. This says, McSkitty needs to check if any other employee elves have left or been affected by the Grinch Industries attack, but the systems that hold employee information have been hacked. Can you hack them back to determine if the other teams in the Best Festival company have been affected? And here are our learning objectives. Understanding the underlying technology of web servers and how the web communicates. We also have understand what cookies are and their purpose. Learn how to manipulate and manage cookies for malicious use. So we are going to be doing some cookies stuff. We are going to be doing some web HTTP, kind of like, hey, internet computers networking right here. But it's going to be a lot of fun. It says HTTPS. For your computer and web server to communicate with each other, an intermediary protocol is required. This is where HTTP, or the Hypertext Transfer Protocol, steps in. The HTTP protocol is a client-to-server protocol to provide communication between a client and a web server. Now, a web server is just another computer, just way out here in the back, that's still kind of saying, hey, I have information to give you. I have pages, I have results that you want to see, and I can hand them to you, you being the client, and you as the client, you just sort of you're on the phone, right? You're calling up the web server, and the web server answers, and they say, hey, yep, I've got all the information that you need. That's the role between the client and server kind of duality there. When you, as the client, start to call them up on the phone, you make an HTTP request. And that request is crafted, and it's kind of has a couple of special properties, right? It has a method and a target. And now the method is what you want to do with this web server here. Do you want to get information, or do you want to post something over there to the site? Those will always be included. The target header specifies what to retrieve from the server, and the method specifies how. When retrieving information from a web server, it's common to use the get method, such as like, hey, loading a picture, retrieving a picture. Literally, actually, take a look at this. When we were requesting this TryHackMe page right here, we had gotten this file included, this nice little Christmas star here. And we sent a get request to retrieve that image file. So that's a good thing to note. It happens all the time, and you'll be able to see it once we kind of get in the weeds here on what this challenge has us doing here. When retrieving information, it's common to use the get method, such as loading a picture. And when you send data to a web server, it's common to use a post method, such as sending login information, like you trying to log in and authenticate to use this website. Or you're uploading your profile picture, or you're changing your profile description. That is all sent in a post request because you're giving the web server information to now do new things with it. Once the server receives a request, it'll send back a response, including any requested content if successful, and a status code. The status code is to tell the client, you, me, us, how the web browser interpreted the request. The most common successful code is HTTP 200 status OK. That's what you'll see if things went well. If you called them up, they answered the phone, and you were able to retrieve, get, or actually set or post the information that you wanted to. So here's an example. You can see this is the raw HTTP protocol here, and take a look. This is you can see that header just right there, and then hey, maybe the server information, again, who we're calling up on the phone, when you make this request, how you want to receive it, and then down below here, I'll go ahead and change this to a different color so it's a little bit more readable. This is the content that you would retrieve as part of that request. That's the message, right? The raw data. The protocol itself is only one small piece of the puzzle. Once content is retrieved from the web server, your browser needs a way to interpret and render the information sent. That's right. This is just structure. This is all the bones and the skeleton, like the blueprint that makes up the information that you might see from the web page, but it's not all the pretty pictures or the flashing colors and animations, right? Web applications are commonly formatted in HTML, the hypertext markup language here, but it's rendered and styled in CSS, or the cascading style sheets. JavaScript, another client-side language, actually client-side as in it runs in your web browser, but dynamic and scripting, and something that could be used to add dynamic functionality and cool features to a web page. In today's web environment, the use of web frameworks has significantly increased in popularity. Most modern web applications use many web frameworks and other web solutions that an end user doesn't even have to see or interact with. Now that could be Ruby on Rails, that could be Laravel, that could be Django, that could be Flask, that could be, Express, right, for the Node JavaScript fanboys. For more information about HTTP request methods and headers, check out the Web Fundamentals room. Let's hop over there. Web Fundamentals is another TryHackMe room that you could explore and work through. It's super good. I want to go verify and check. It is a free room. So, hey, if you aren't subscribed to TryHackMe, you can still jump in and play and kind of get a good idea as to what's going on in that activity. But now let's move on. Now let's talk about something fun and something cool. Cookies here. Cookies are how authentication really works. It's the bare bones. It is the vessel. It is literally the core and raw structure of how you can log in and the website knows that you're actually logged in and you are who you say you are. This is all because HTTP right here, HTTP is a stateless protocol. And what that means is that it doesn't keep track of the previous communication that was done. You're calling up on the phone to your buddy. Turns out your buddy has amnesia. He doesn't remember anything that you just said past what you just said. So you have to kind of have a secret message or something part of and included in every single thing that you say so it knows, I'm talking to Buddy Bill or whatever. That's the use of cookies here. So when you send requests to a web server, the server cannot distinguish your requests from somebody else's. Now let's imagine you're the amnesic server and you're getting phone calls from like everybody. Phones are ringing off the hook. To solve this stateless problem and identify different users and access levels, the web server will assign cookies and create and manage a stateful session between the client and the server. Cookies are like tiny pieces of data or metadata, right? And information locally stored on your computer that are sent over to the server when you make a request. Again, that's what I was saying. Hey, that's the kind of secret code when you're calling up the server and you say, hey, 123792, this is John. And then it knows who you are and what you're doing because you were able to authenticate and you passed it the cookie, a secret special token. The thing is, you don't want other folks to know what that cookie is. You don't want them to know your secret passcode. You don't want them to know that little token that could be used to say you are who you say you are. Cookies can be assigned any name and any value, allowing the web server to store any information that it wants. Today we'll be focusing on authentication cookies, also known as session cookies. Authentication or session cookies are used to identify you and what level of access you have for your session. So here, below is a diagram describing and assigning and using a cookie from the initial request to the session request. So this is going to be fun. I'm going to be able to draw all over this and kind of make a mess here. Check it out. Here's the client over on this side. Let's see if my pen wants to work. Oof. We did our best, guys. I don't know why Epic Pen always tends to lag over here. But of course, you have your client, the web browser on the left-hand side, and you already know, hey, this is our server here. Now, as this happens, and it goes sequentially, right? You make one HTTP request, and you can see this is a post request right here. We go ahead and post, hey, I want to log in with this username and this password. And that works. Oh, and I can actually draw better arrows here. So the server goes on and says, cool. I see who you are. I know who you are. Now I'm going to say, cool, dude. Set this cookie so I actually have an understanding of who you are, and that way we know as we're talking to each other. Here's the secret code so that you can be who you want to be, Barbie girl. Now that this user is authenticated, they go do whatever they want to do on the actual application. They'll go in and say, hey, I want to go make changes in the admin portal, so they'll send a GET request to go receive that page. And because it is including the cookie here, let's draw a little picture, let's draw a little... do I have a circle? Yeah. Here's my cookie. It just looks like a donut. Looks like a yellow donut. I don't have any good like cookie colors. And then the server comes back and he's like, sweet man, I know who you are. I can see your cookie. You've got the secret passcode. Check it out. Here's all the information that you wanted, because it was able to determine you are who you say you are based off of the cookie. And that's that explanation. Hope that was fun. To begin the process, when you send a request such as a login request, your browser sends this information, blah, blah, blah. This is everything that I just discovered and talked about. There is one good thing here. It says when the server receives your GET request and cookie, it'll locate and sometimes deserialize your session. Deserialization is the process of taking data from a given format like JSON, JSON, the JavaScript object notation, and then rebuilding it as a logical object or some kind of data format that a computer programming language, maybe PHP, maybe Python, maybe JavaScript, whatever, it can actually read and interpret and understand. It's not just a flat, boring chunk of letters and numbers, right? Because that's just a data representation we want to bring into a form that our programming language knows how to work with. If all of that succeeds, the web server goes ahead and responds, as it does over the phone, with a 200 AOK, thumbs up, you're good, here's your stuff. Now that we understand what cookies are and how they're used for, let's dive into their contents. Ooh, okay. Now I gotta be honest. I gotta be completely honest here. Cookies are made up of 11 different components. 11. And that's a lot. And some folks, maybe you're like, dude, I can count all those things on my hand. I have 10 fingers, but I know that I need 11 because that's how many components in a cookie. Each component of the cookie, whether it's a name, value, domain, path, expire, set, size, secure, same site, etc., I would venture to say, unless you're doing some crazy hardcore witchcraft and voodoo stuff, you don't need to know all of the ins and outs of the, stuff beyond this. I'm saying, I think really the name and the value are the most important pieces that you will mess with as you tinker with and explore cookies. All of this stuff, maybe sometimes you need to worry about it. Not always. So if you are willing, if you don't mind, press the I believe button with me. And that way you don't have to overwhelm yourself and thinking, bro, I don't want to memorize and study and make flashcards for the 11 different components of cookies. I got to be honest. Sometimes it's just the name and value that really mean the most here. But of course the domain is like, hey, where is it actually set for a specific website? And the path, where is it okay to be used? When the cookie expires, it's just a kind of important thing. But the size, HTTP only, some of these might not always need to be in the weed with. You should know that they exist, right? Because they are settings and they are values for a specific cookie. But be that as it may, or whatever idiom you say to wrap up a thought that you don't know how to wrap up. Looking at all the components, a cookie may seem intimidating. There's no need to worry as attackers. Oh, TryHackMe just said this. TryHackMe's taking the words right out of my mouth. Cookie components are always prepped in pairs. The main pair is that name and value, because that's the most important part, right? This will define the name of the cookie and the value of the name. The second pair is the attribute value pair. This defines an attribute of the cookie and the value of the attribute. That's actually setting it here when you're using a set cookie header in an HTTP request or response, right, from the web server. When the web server said way back here, they were like, hey, we're setting a cookie with this web server response. All of that information that you just saw below is what's going to be included in there. Just here. Now, the thing is, cookies are stored locally, as in you carry them with you, right? You're the client, of course. So what if you could tamper with and change that cookie, and then when you give it back to the server, when you're calling the server up on the phone, you say, hey, remember how I used to be Bill Bob? Now I'm Joe Schmo because I know the passcode 72918. And the server's like, cool, dude. And that's the idea. That's how you can manipulate cookies, and you could do specific stuff. You could get unintended behavior determined by the web developer. That's why you don't want to have your cookie shared. But if you are acting as the adversary, you're putting your hacker hat on, you kind of want maybe to get access to someone else's cookies, because then you could access their session and access their pages on a web server. That's the idea. That's the gist there. Now, you could do this in your web browser. Like, you can just straight up do this in Firefox, Chrome, Edge, Internet Explorer, Safari, Opera. I don't know what you're up to these days. Brave, is that what all the cool kids are using? Developer tools can be accessed by pressing F12 or Control-Shift-I on your keyboard. In your web browser, there is a little extra fun features called the developer tools, or sometimes the browser tools. Once the developer tools are open, to access your cookies, navigate to the storage tab in Firefox or application tab in Chrome or Edge. Select the cookies drop down on the left-hand side. And this is everything that you might be looking at when you're working on a page. Storage, application, and the cookies tab. We'll kind of set all that here for you. Cookie values might seem random at first, however, they often have an encoded value or meaning behind them that can be decoded to a non-arbitrary value like a JavaScript object, like JSON, kind of as we were discussing before. From an attacker's perspective, you can decode the cookie value to identify the underlying objects. Once you've identified the underlying objects, you can modify them to whatever you want. Like, again, hey, the account name that you try to log in with, Bill Bob, change it to Joe Schmo. Is there an isAdmin parameter, like a true or false or a 1 or a 0 that says, hey, are you a super user on this website? Totally change that. You can resend the cookie back, and if the web server interpolates it and understands it, maybe you got access. Below is a summary of how cookie values can be manipulated. Obtain a cookie value, like a regular, normal one, when you're calling up the server on your phone, for just registering and signing up for an account. If you decode that cookie value, identify the object notation or the structure of the cookie, and then change the parameters inside the object to a different parameter with the higher privilege level, like admin or administrator, right? Kind of that idea I was just mentioning. Now, if you re-encode the cookie back to what the server is expecting, because it needs to be able to know that this cookie hasn't been changed or tampered with. It wants to look as similar to a normal and regular cookie as it could. Like, I'll bring this back to the actual case of cookies. Look, if you try to bring grandma chocolate chip cookies and then all of a sudden you had oatmeal cookies given back to you, you're like, what the heck? This isn't what I would have expected in this transaction here. They know something nefarious is going on, or they just can't handle it. Maybe grandma's allergic to oatmeal cookies or something. I don't know. And then you do something with the cookie. You let it invoke itself. You let the server handle it and read it, oftentimes done by refreshing the page, because then it forces the server, when you make another GET request, hey, can you tell me what's going on? And it'll process and do all of it. If you want to learn more about all about that, there are some other rooms in TryHackMe, HTTP in detail, or other authentication bypass challenges in different TryHackMe rooms. Let's go take a quick peek at some of those. This is the Web Fundamentals one. Down below, we have HTTP in detail. And I will scroll down to the very bottom. Also, again, a free room. Fantastic. Authentication bypass. That's a subscribe one. Okay. So, hey, just know what you're getting into if you're tackling some of those other fun extracurricular TryHackMe rooms. But now let's get on to the challenge. Let's get on to our task here, what we are actually trying to accomplish. Let me go ahead and close out those other tabs because I do want to be able to open up this new one here. It says open the static site in a new tab here. All right. So that's this link. I'll go ahead and click on that. And this is the web page I'm greeted with, the best festival monitoring, with some login or sign up form, and I guess some snowflakes falling. Could I turn the snowflakes off? No. It's just a facade. Just a lie. Just like me when I put on Santa's costume. So we open it up, we register an account and verify the cookies using the developer tools in your browser. All right, so hey, let's go ahead and say John Hammond, password, please subscribe. Oh, and I need to actually sign up, right? Thank you, LastPass. Use a password manager, guys. Please subscribe, and let's just say john@john.com. Create an account, here we go. Uh-oh. So Google Chrome wants me to save this password. LastPass wants me to save this password. But it says, hey, you don't have permission to register an account currently. Please contact an administrator for more assistance. Did I get a cookie, though? So if you wanted to, as TryHackMe mentioned, you can hit F12 on your keyboard or hit Control-Shift-I on your keyboard, or you could very well right-click and do like an inspect element. And that will pop up, hey, the notion here of the developer tools. Now, I'm going to go way, way over to the side here because there are going to be some things that we particularly want to see. This isn't, I want to verify what I just said was A-okay. Yeah. So this opens some other things. When I hit Control-Shift-I or when I hit F12, it's still the developer tools being opened. I am probably Dumbo and not seeing where storage is, but I suppose it's under that application tab, right? So if we go to application and then we go to cookies, can I expand this? And let's see. Yeah, there is a Static Labs TryHackMe.cloud entry there. Ooh, so this is a kind of connection that we have set up. We see a list of cookies with their name and value over here. One of these is for Font Awesome, and the other, as you can see for the domain here, is for Static Labs TryHackMe Cloud. Now, this value you can see down below. My face is just about in the way, but it's a lot of letters and numbers. Seemingly, these are more numbers than they are letters, and interestingly, all the letters are A through F, which sounds a lot like hexadecimal. And I don't know if TryHackMe is going to maybe give us that clue, but we did see, hey, we found our cookie. It says, what is the name of the new cookie for your account? So that was user auth, right? We were able to see that right over here. And now if we go back, we can submit that. I'll hit enter. What encoding type was used for the cookie value? There is a hint here in case you didn't know, but I'm going to take a guess that that is hexadecimal. Yeah, okay, cool. What would that hint have been if we wanted to click on that? Use CyberChef to decode the value. Ooh, okay. Let me fire up a CyberChef link. There we go. If you wanted to, if you just genuinely had no idea what the heck we were looking at, I'll copy this cookie right here. I'm gonna right click, select it all, and copy. If I bring it into CyberChef, if folks aren't familiar with CyberChef, CyberChef is an incredible tool to be able to do different things with data or represent it in a different way. And you can stack a lot of different operations, whether it's whatever you want it to be. And then you can clear this out or manipulate them or move them around and see the input and output like rapidly. So that's a ton of cool stuff that you could do with this. CyberChef is super duper handy. It's all online, totally free. So, hey, if you wanted to, you could explore different recipes and see what the output is. Base 64 is not it. And 2 is like doing the operation in one direction. From is doing it the other operation in the other direction. So like encoding versus decoding. If we wanted to decode this cookie, it says, hey, we could convert a hexadecimal byte string back into its raw value. They give an example here, all these. And let's take that. Here we go. The hexadecimal representation is just a number system, right? It's base 16 rather than base 10 like we normally count and use in our language, which is base 10, right? 0 to 9. This time it's 0 to 9 with an A through F in hexadecimal, just like you saw up here in the input. There we go. We have company, the best festival, is registered equals true. Username is John Hammond. So that's it. This looks like the same representation that we saw above. And this, as TryHackMe had mentioned, the structure with the curly braces kind of wrapping around it. Let's see, they had another example here. JSON, right? This is that structure. And I'll zoom in just a tad on that to focus on that. When you see the curly braces, and when you see kind of a key value being set with the colon to another actual value, age colon 50, eye color colon blue, whatever, that structure is JSON. Each of these are actually kind of represented and separated by a comma here. You can see that after each entry, but that is just a method and a way to store data. It doesn't actually mean anything. It's not code. You can't execute it. It's not going to run. You're not compiling or running any JSON, but it's a representation to show data and information. And that's why they literally call it the object notation, because it's the notation. It's how it's presented and how it's stored. So that's JSON, JavaScript object notation. We can manipulate the cookie and try and bypass the login portal. What's the value of the administrator cookie if we try to change our username to admin? So let's go back to CyberChef and do that. Let's say our username, if we kind of took this output here down below, I'm actually going to do something weird. I'm going to remove everything from input and clear out my CyberChef operations, and I'm going to paste it in here so that now we could modify and tinker with what we actually want to change here and manipulate this cookie. Let's change that username to admin, typing that in, and let's change this to hexadecimal. Now you can see this could take a delimiter here. You could click on this and change it because this is full of spaces. We don't want any spaces, so let's change that delimiter to none. And now I have this big long string here. Double clicking, right clicking, copy and pasting. And let's go give this back to TryHackMe. Here's the value. Hit submit, and that's correct. Now let's go back to our cookie editor here in our developer tools on the static website, and let's try to right click a cookie and edit that name or edit that value here. So I could slap this in, replace it just like that, and we could see that that was able to be changed and manipulated down below. Now, if I were to refresh the page, you could click on the refresh button in your web browser, or you could hit F5 or whatever. I really, really recommend almost everyone, when you're trying to refresh a web page, hit Control-Shift-R. That makes like a hard refresh without caching any information in the background. So any pages that you previously requested and your web browser knows, hey, I don't need to request those again because I already requested them. No. It tells your web browser, look, I'm going to request everything no matter whether or not I've seen it before. And that will kind of give everything a clean slate. So if you've done any manipulating, like changing or tampering your cookie, Control-Shift-R pulls it all back down fresh. Let's do that on the keyboard real quick. Ooh. Did I miss? Did I make a mistake? Very, very likely. Let's check out my user auth. Okay, no, it is the correct thing, but I don't know if I've actually told the server, hey, I want to set that cookie. Let's go verify that one more time. We've made this cookie, and if I wanted to go back to the home page, ooh, yeah, this is trying to do some like GET requests. I want to go back to the actual home page. There we go. Okay, so that was just kind of an idiosyncrasy at the very, very top of the web page. I may have changed the value for the cookie, but it was still taking me to a page that wasn't trying to log in or get me anywhere. It was already telling me, hey, you can't log in because it saw in the URL from those get parameter values, hey, you are not allowed to log in. So, all right, so we have some operations or some teams here that seem to be either responding or not responding. I'm assuming this green is good as a status, red is not, and yellow it could be something else. And are these actions? I don't know what those are. Let's go back to the room first, see what we're doing here. Team environment is not responding. That is HR. Go ahead and submit that. Team environment has a network warning. Oh, that's finance. So, hey, listen, I might have just steamrolled over probably the most important part. What we did just then when we manipulated that cookie is ultimately an authentication bypass. And that's the danger, right? When you either know someone else's cookie or you could figure it out because it's represented in such a weak and easy way. Like, you shouldn't find yourself with web servers that will just have JSON encoded data that you could easily manipulate and tinker with. We didn't have to know the admin password. We didn't have to change or modify our permissions. We literally just changed our name to admin, and that's a weakness. That's a serious flaw on the web server's perspective. Us as the client, us as the, acting as the adversary, putting on our hacker hat, that's something that we could use and abuse, but this is the learning point. This is the value when we kind of see, hey, JSON in the cookie, we can manipulate and change that cookie, and ultimately you have that power, even as the client, even as the end user. That's not a server-side thing. You can change that. So there's the danger in that. All right, hey, we've got all of this figured out here. Sorry, it looks like it is the application operation or that team that is having trouble here with their connectivity. Looks like I can click on stuff, but it doesn't do anything. I guess that's the speed test. But hey, let's go and answer that. Application is a team that's having a bad time. And if you want to learn more about any authentication bypasses, we suggest trying out this room, application bypass. Tasks get released each day and progressively harder. Yep. Kind of as we knew from yesterday. Come back tomorrow for day 3's task, where Namsek will be recording a video walkthrough. Ooh, he's quite a fella. He's quite a handsome man. That's going to be a ton of fun. Thanks so much for hanging out, everybody. This has been the day 2 task for the TryHackMe Advent of Cyber 3, our 2021 edition. And we learned a lot, There was a lot of reading, there was a lot of learning, a lot of cookies, HTTP stuff. But boy, oh boy, did we get into some good stuff. And I hope you had fun. I hope this was educational. I hope this was entertaining. And I hope it's keeping you happy, healthy, and excited for the TryHackMe Advent of Cyber 3. We're having a ton of fun. I'm pretty excited about all the upcoming rooms. And there are just so much activities for the holiday season. Like, everyone's doing a CTF, everyone's doing a great game, everyone's doing some fun cybersecurity learning. And I guess we're just going to have to completely neglect and ignore our friends and family because we just want to hang out on the keyboard. Do some CTFs. Thanks so much for watching, everybody. I love you. I'll see you in the next video. Take care.